What's up, everyone? I am back in my garage, and in my last video I showed you my 3D printer and the frame, and you can probably hear it running now, and the frame for the upgrade to my 3D printer. Well, it's not done just yet, but it is very, very, very close. It's functional, it's just not completely 100% usable. You want to see? Here it is. Again, I can't fit it all into one shot. But it is completely functional. As you can see, it is printing the bullets for this, which is a Harlequin. It is the gun that Harlequin uses in the Suicide Squad movie. It's a little bit difficult to do this with one hand. There we go. That's the gun. And then here's the barrel. This whole thing was printed on this printer. Granted, it's in multiple pieces, but all printed on this printer. And couple problems that I had while doing this. Sort of the main one that's been the biggest issue right now anyway is that basically this aluminium plate, there's a heater pad underneath it, and that aluminium plate is, well, it is die cut, and then it is basically, before they turn it into a paella pan, that's the black, and we were able to get one. So that aluminium plate, it's not perfectly flat. It has about 1 millimeter of tolerance when they die cut it, because it basically comes in sheets, and then a big die comes and presses it out, and then you get that, and then they put it in another die to turn it into the pans. But a pan doesn't need to have that much tolerance, so they don't really care. Whereas this needs to be tolerant, it needs to have tolerances within sort of 0.05 to 0.1 millimeters, which is nothing. I mean, I don't know where it is, but we even bought a dial gauge. Let me just go get it quick. We bought one of these, which is, it's a dial gauge, it's meant for sort of precision engineering stuff. And it showed us, I mean, if you look, this has sort of a lot of, it's very, very fine, and it'll move about that much, which is about 0.5 millimeter, sometimes even more, to 1 millimeter at its worst and extreme points, which is not good. It basically meant, that over here it was really, really high, and then over here it didn't work very well. And I ended up drilling more holes to try and bend it straight, but then there's a screw over there, and then there's a screw over there too. There, that little black thing. And then there's one under that tape. And it didn't want to work out. So that was a really big issue. It's to the point now where I can print in an area from about here to here and about that wide. So it's usable, it's just not 100% usable. It's 100% functional though. I mean, it is working. It's working as a Delta should, it's very well tuned, and I'm happy with it. We need to get some machined aluminium plate that's within our tolerance needs to get it to be 100% usable. And another thing that I don't really want to admit is, so I just assumed we have a silicon heated bed, and they draw a lot of power. I had a 350 watt power supply. I don't know why I didn't do the maths. I should have, but I just assumed that it would be enough to power it. and it wasn't, because the motors and the hot end and all that take up roughly 5 to 10 amps. Probably more close to 5 amps. And that's at 12 volts. The heater bed can take up to 40 amps. The power supply can only supply 16. So I broke a MOSFET. Well, I completely fried a MOSFET. Luckily, nothing else in the electronics was damaged, so I was able to desolder it. So I put a new one in, works no problem. And yeah. And another thing you might be thinking about with the bend on the bed, there's glass there. Shouldn't that be perfectly straight? I thought so too. But it turns out that glass bends a lot. It follows the contours of the metal very, very well. And it wasn't straight. But back onto the heated bed. This is the power supply that I was using. It's just a normal PC power supply. It's around 350 watts. It can supply 17 or 16 amps on the 12 volt rail. This is the power supply that we got to power the bed. It is a 12 volts, 50 amp power supply. Yeah. Overkill much? No, it's actually not overkill at all. But I will say, in my old printer, the bed heated up very, very slow. This heats up amazing, and that's with a 6mm aluminium plate and 4mm glass, and it heats up really well. And then that's just a, because obviously you can't run 50 or 40 amps at its maximum through a tiny little MOSFET that's on there without any cooling. You can run probably around 10 to 15 amps, no problem, but without any cooling, you're going to fry it. So what we're doing is taking the, and I've got the electronics in bang bang mode, which is basically turns it on and it turns it off. That's just for the bed. The hot end is still controlled through a PID controller. But it goes through the relay, which then switches the power from the power supply to the bed. And this is some like really, really high amperage cable going down to the bed. And then that's just an automotive relay. It can handle like 50 amps. And then there's the motors mounted down here. They do get a little bit warm, so I might have to put some cooling onto them. But that's at a bit of a later point. And yeah, a lot of the pieces of this printer, like these pieces and those pieces that actually sort of connect everything together, was 3D printed on my old printer. And yeah, my old printer is currently decommissioned, but I'm going to be butchering a lot of the, because it's still got the motors in it, because I didn't want to take the motors out to build this one, because then that one would be out of commission, and what if I needed a part? So what we ended up doing was getting 3 new motors, and then we were able to connect it all together without decommissioning the old printer, and then basically just swapping over the electronics, which actually took half a day, which really wasn't that bad. And right now, the glass bed is just taped on with some sort of Kevlar tape. And then I do still have the brilliant, just sort of ratcheting clamps that holds the spool up for the filaments. But that's, yeah, it's a bit of a wiring mess right now. But what I want to do is get it completely functional. Then I'm going to, again, because I can print something that's 30, a little bit more than 30 big, completely circular, and like 40, I think the final height is roughly 40, about 41 centimeters high printable height, so it's quite big. So yeah, and then I'm still using the exact same extruder from the old printer and the exact same Rams board. I don't know if that's in the shot or not, but there it is. That's all the same, but I am planning on upgrading the electronics to a 32-bit based SmoothieWare. It's going to be running the SmoothieWare firmware. It's 32-bit based. It can do the Delta processing a little bit faster, and it's just, I think it'll be better because, again, I'm going to be butchering the old printer to make a new printer, and I'm going to put those electronics in the new printer. Well, this is the new printer, yes, but I'm going to be putting those electronics in the smaller printer that I'm going to be building, and then I'm going to get some newer electronics for this one, because it's a little bit bigger, and the stepper motors in the I think it's called a MKS Gen 1.2 32-bit controller board. It has a DRV 8825 stepper motor drivers, which they can output a little bit more power, and they're just a little bit more robust, and they're built in, and it actually doesn't work out too expensive. But yeah, that is my 3D printer, my new 3D printer. Again, I'm just running it off of Repetier host, and it's running Marlin firmware. Again, it's what I tried running Repetier firmware, and I couldn't get it to how I wanted it. Marlin, it just works so well. Again, some people have had a lot of luck with Repetier. I haven't. I could never get it to work right. And I started learning how to play around with the EEPROM settings, but again, it didn't operate as nicely as Marlin. Yeah, and then these rods are just 6mm carbon fiber rods with the rose joints, I believe they're called. Rose joints, ball joints, universal joints, whatever you want to call them. I believe they're called rose joints. And we've just got those, and I glued them with two-component adhesive with a little jig I made. I don't know where it is. Basically, I just took a plank of wood, put 2 bolts in it at the exact distance I needed, and then pushed these through, glued it together, and they're all exactly the same length. It's the easiest way to do it, and I don't really see a reason. We were thinking about putting in adjustable pieces, but then we would have had to add aluminium to it, and I didn't want it to be that heavy. And then over here to mount it, we drilled a hole so the hot end pushes up and then slides in. And then that's just, they call it phenol fiber. It's basically just fibers of wood with phenolic resin. It's really, really stiff and really strong, so we just got a copper shim in there, and then we just ground that down to the point where it slides in really snug, and that doesn't move at all. There's surprisingly little backlash in the system. And the end stops are just mounted again with 3D printed parts from my old printer. And yeah, like I said, this was all done on this 3D printer. It's not perfect, admittedly. It's a little bit warped, or one of the pieces are a little bit warped because it was the first thing I did. But it's I couldn't do anything nearly this big on my old printer, and this wasn't even strenuous for this one. And this one can do a lot bigger. I mean, something like this, which I had to do in 8 different pieces. You can see it's like in 8 different pieces. This could do in 1 piece. I'm planning on doing like full size, like if you think Iron Man or Master Chief helmets in 1 print. I want to print myself a full size Master Chief costume. It'll take a shit ton of filament, but again, filament it lasts quite a while, and you get a lot out of it. I mean, this is a reel that I got about a month ago, and it's got probably about 20-25% of plastic still on it, and then I've still got another reel over there. Not that you already saw that because I was so juddery, but anyway. So yeah, you can see the quality is actually pretty decent. Again, as with everything, you can do more tuning to get it to run right. But yeah, so I think that'll be it for this video. Just a little bit of an update on my 3D printer. I plan on building a lot more because I'm a little bit addicted, just a little bit, and I love it. Again, I could never like sculpt and do anything like that with my hands. But I was always quite mechanically minded, and considering the first printer I built, I look at it now and I look at this and I think, God, what the fuck did I do? This we did well. The first one I did as a proof of concept. This one we did properly. But again, I think it's awesome, and yeah, that's going to be it for now. So, goodbye.